Good afternoon. I did actually figure this out right after class. I was being an idiot. Open it up. So all I had to do field list. You just click it and drag it to values. And it creates the column. I know I told it to show. Why is it not showing? Drag and drop. And if you notice, that's going to add another column if I drop it. Like that. Right, and then from there, it's very easy. Just make sure you're clicking the table itself. Insert, and then the graphs you want. So bar graph. And pie charts right now. And then you can change styles and everything. So it was something simple. Oops, I didn't format this. Format this. That's not good. This is not a button to touch on. So let's come back. We're looking at now quantitative data. We're going to revisit the frequency table, but now for quantitative data instead of qualitative. Because of the sheer number of possibilities with continuous quantitative data, we don't do each category like we did with qualitative. We look at a range, right, or an interval of values. These are your classes, or your bins. If it is discrete quantitative, and you have a small number, like number of pets owned, let's say, chances are the values are going to be less than 10. You can treat it like it's qualitative and just do a category for each number of pets. But when you're starting to talk about things like quiz scores, test scores, height, weight, you're going to have to create classes. You're going to have to create bins. So that's actually just what I said there. Right, so number of pets, you can even do something like, if you have the odd collection, someone who has like more than 10 pets, you can just create a category of 10 or more. Right, so for continuous though, you want to set up your bins, you want to set up your classes, and the classes have to be equal width. So think back to algebra when you're looking at intervals, right? You had open and closed, right? Parentheses and brackets. Open meant what? If I just look at, let's say, the simplest of numbers. What does that interval mean?
What's the question?
What does that interval mean? What's that interpretation? What is it? Zero less than x less than 1. Endpoint's not included. Start to look familiar. Number lines. All of that with your open points. Remember that? No, that's not the one I want to do. Let's do this one instead. Zero's now included. And I bring this up because this is typically how bins are going to be represented. The notation in this book is a notation that is not used. I understand why it's introduced, to try and keep it simple, but it's not used at all. When we look at Excel, it's going to be using the interval notation. Lower class limit is the smallest value that can go in the class. That is your left endpoint. The upper class limit is the smallest value that can go into the next class. Right? In this example, your lower limit would be 0, your upper limit would be 1. And your next class would start at 1. And your class width is just the length of that interval. Right? The difference between the upper and lower. Frequency, kind of already know what that is. It's how many values fall in that class. So using the 0 to 1, it's how many values would be between 0 and 1, not including 1. And then you have the frequency distribution, which is just a frequency table. And of course you have relative frequency, which is all done the same. So the only difference now is you have classes instead of categories. When trying to represent this visually, remember for qualitative, we used bar graph and pie chart. Bar graph is the more relevant one here. When you're dealing with quantitative data, it's now called a histogram. The idea is generally the same. There is going to be a slight difference. The bars are now touching. In a bar graph, remember you had space between your actual bars. In a histogram, they don't. When one rectangle ends, the very next one begins. You do want to make sure that the width of your rectangles are the same. That's not really a necessity in a bar graph, but you still tend to want to keep them the same. It is necessary here. And I already mentioned that your bars are touching. Right, your class limits are on the x-axis. Y-axis is the frequency. You can also, like with bar graphs, have it the other way around horizontally. It's not as common. Traditionally, it is more common to have the bars vertical, not horizontal. And there are two generally accepted ways of drawing your rectangles. The first is on the axis itself. Your ticks would be your class limits. Right, so 0, 1, and then your rectangle would actually start at the 0 and end at the 1. Your next one would go 1 to 2, 2 to 3, so on and so forth. Another way is your ticks are the midpoints of each class. Right, so 0, 1, your midpoint would be 1/2. And then you draw your rectangle with the midpoint as the center. I've seen it done both ways. Well, just like with bar graphs, we can actually identify the shape of a distribution, but with quantitative data, it's more relevant because it has to be ordered. This is the most boring type of distribution. This is called uniform because everything's the same. Yeah, that doesn't exist. That data doesn't exist in nature. Well, this shape should look familiar. That's symmetric, or bell-shaped. And again, any histogram that kind of resembles that, where your peak is close to the center, we just call it as symmetric. This one is right skewed. Or you're probably also going to hear me call it right tailed. Clearly left skewed. Or again, I may call it left tailed. Mode is your peak. But again, now keep in mind, since we're dealing with classes, when you're looking at mode in this sense, it's not a single data point. It's what class occurs most often. And then, of course, unimodal, bimodal, trimodal, one mode, two mode, three modes. You could, in theory, create a pie chart with this and be done the same way, except now it's no longer categories, it'd be classes, right? That doesn't happen too often. But theoretically, you could. Another type of representation we'll be looking at is called the stem and leaf plot. We'll look at that next time. And those are actually the only three actually that we look at. The quantitative, we look at the frequency tables, histograms, and stem and leaf. But there are a lot of them. You have time series. You have polygonals, which are interesting. When we start looking at paired data, scatter plots, actually we'll be looking at scatter plots. But there are a lot of them. Generally speaking, there's an entire chapter dedicated in those textbooks just to the ways you can represent data. No, I didn't even realize this is one of my examples. 40 households were sampled, asked how many pets they have. There's the results. Frequency distribution, as well as relative frequency. We'll start with that. Number of pets, clearly quantitative, right? That the number actually has meaning, but it's discrete. And it looks like the highest value is 5. So that would give you 6 categories. That's small enough where I don't have to worry about creating classes. I can just treat this as it's qualitative. And each class is just the number of pets. So this is just identical to what we did last time. I'm actually going to call it count. easier if I can. Our classes. Zero to 5. Those are the 6 categories. Now it's just a matter of coming here and counting how many times each one occurs. Let's start with 0. 1, 2, 3, 4, 5. And I can actually do the relative right away. Why? Because they told me how many there are. There's 40. Five out of 40, which is approximately 1/8. Not approximately, it is 1/8. I don't even worry about approximation. 1/8 is 0.125. It's half of a quarter. Quarter is 0.25. Now count the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yay. So that's going to be 15 out of 40, which is 3/8. 3 times 0.125. Same as what's 3 times 12.5. 3 times 12 is 36. What's half of 3? 1.5. 37.5. And 375. Now count the 2s. 4, 5, 6, 8, 9, 10, 11, 12, 13. I missed one. 2, 3, 4, 5, 6, there it is, 10, 14. 14 of them. And 14 out of 40, which is 7/20. That's an easy one. What is 7 times 5? So 0.350. And 7/20 is 35%. Threes. 1, 2, 3, 4. I counted 4. Oh, 4 out of 40, that's another easy one. Four, 1, this one is also relatively simple to do, 1/40. 1/20, 0.05. 1/4 is half of that. Half of 5 is 2.5. 0.025. And 5, there was only 1. There's our distribution. Then just make sure that they sum up, right? Counts do sum up to 40, and your relatives will sum up to exactly 1, which is what we want. All right, that's A. That was probably the hardest one. B, what percentage of households have at least 3 pets? This is going to require to know what at least means. And you're going to want to know this because when we study probability and actually beyond, we need to know stuff like that a lot. At least, at most, no more than, no less than. So what does at least 3 mean? Which means what? Mathematically.
Greater than or equal to 3.
Greater than or equal to 3. In context here, though, it's actually not going to be entirely greater than or equal to 3, right? Because we only go up to 5. You can just add up those frequencies. Which is what? 0.150? But that's not what they were asking. Percentage. What's 0.150 as a percent? 15% of households have at least 3 pets. List modes. Again, this one should be easy. First, how many modes are there? One. What is it? 1. Mode is 1 pet. And describe the shape of the data. So just looking at the table, what's the shape? What does it appear to be? Appears to be right skewed. Right, your humps are on the left. Which means your tail is on the right, so right tailed. Now, interesting bit of trivia, actually. We're going to see this as well. This required us to count, right? Counting is hard. You laugh because you think it's not. There is an actual branch of mathematics called counting theory. Counting is really hard. We're going to have to do that with probability too. So this is a classic example of a counting problem. Right? You have a pool of 30 students, right, running for officer positions. Let's just make it easy. President, vice president, secretary, and treasurer. How many different ways can that cabinet be made up? That's a counting problem. It's 30, choose 4, I believe, which is a very large number. I think it's choose because I'm pretty sure the binomial order matters. Or maybe it is the permutation. I will say it. The counting's hard. Grades are recorded we're going to create a frequency distribution of the grades using a class width of 10. And do they want frequency as well? They actually don't. Okay. Let's not call that count, let's call that grade. Is this data already ordered for us? That's going to make it easier. What's the minimum? What's the maximum?
98.
There are a few ways of creating the classes. You could just look at the minimum and say, okay, well, there's the lower limit for the lowest class. With a class width of 10, that would mean that would have to go up to 62 for the first class. 52 to 62, then be 62 to 72, 72 to 82, 82 to 92, 92 to 102. Another way you could do it, what's the maximum?
98.
You could make it so that your very last upper limit's 99 to count for that 98. And then use a class width of 10 and work backwards. Right, 89 to 99 be your last class, then be 89 to 79, or right, 69 to 79, 59 to 69, and then 49 to 59. Those are valid. I could also go, okay, well, I see a 52, I'll just make the first lower limit 51. And then go from there. I'm going to go a more traditional group for grades, though. I'm going to start at 50. I'm going to be 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. Notice I'm not including anything less than 50. While you're not technically wrong if you do that, you really don't want to have classes before with counts of 0 and classes after with counts of 0. So I don't want to include the 40 to 50. There's no counts. Don't include 30 to 40. There's no counts. These are the two notations. This is the one that occurs in Excel. That's the notation that's used in the text log. And that symbol represents up to but not including I'm just gonna tell you right now, I'm not gonna use that notation. I've never seen that notation before this class. I'll either stick with that, or if I get really lazy, just 50 to 60. And now it's the same thing. We're going to come back to the data, count all of the values between 50 and 60, and remember, you don't include 60. Having it ordered makes it even easier. There's two of them. Now look at the 60s, 5. 70s, 7. 80s, 8. 90s. Notice that if there actually was a perfect score on here, I'd need a new class. I'd need 100 to 110. Which, for all intents and purposes, is just counting the number of 100s there are. Unless I'm nice enough to get the extra credit, you can get more than 100. Part B is asking what percentage of the class scored below a 70. So again, interpret that. What does below 70 mean? Less than 70. That'd be these two classes here, right? So there's 7 out of, they didn't tell us how many scores there are. So let's try to add up the counts. Let's make this easy. 8 and 7 is 15, 15 and 5 is 20, 8 and 2 is 10, 20 and 10 is 30. So not 30. Which is what as a decimal, approximately? What'd you get? What was it?
0.22.
Exactly?
No. 0.233.
0.233 what? Repeating?
Yeah, 0.23.
What's that as a percent?
22%.
23.33%. Just about a quarter of the class got below 70. Let's actually examine that a little bit more. Why 70? I have to know why. What's significant about a C? In college, that's considered passing. Technically. Technically, a D is passing, but it won't count for credit. You have to get a C or better for it to count as credit. That's actually failing in grad school. B is passing in grad school. And that's kind of frowned upon too. If you get a B in a class, they kind of look at you weird. I know a lot of engineering programs, if your GPA drops below 3.7, they just kick you out. 3.7 is A minus. It's the lowest A minus. Histogram. Perfect. I already have something drawn for me. So again, notice where my origin is. It's not 0, 0, is it? It's 0, 50. Or 50, 0, rather. For histogram, that doesn't matter. Again, you don't really want to include less than 50, because it's all just going to be empty space. $50 to $60, 2. It was then what, 5, 60 to 70? And then 7. Then it was what? 8 for both, right? There's the 80 to 90. And then 90 to 100. There's our histogram. Last one it wanted is the shape. So here we actually have the histogram, so it's easier to see the shape. What's the shape? Left skewed, right? Adult heights range from 150 centimeters to 195 centimeters. We plan to randomly survey adults asking for their height and create a frequency table with 6 classes. Determine class width and the classes to use. Right, so if we're going 150 to 195. So your data will be a range of values. The minimum will be 150, the maximum will be 195, so what's the range? What is it?
45.
How'd you get it?
195 minus 150.
Some people think about the range. I don't need all the data. If I know it's 150 to 195, I can calculate the range without any other data. Now, technically, you're incorrect.
Centimeters.
Centimeters. Units are provided, so you have to give units. Here's what we're going to do. We want 6 classes, and we know that the range of values is 45 centimeters. Sorry, width. So you just take your range divided by however many classes you want. $45 divided by 6.
So 45.
It's actually exactly 7.5. Try to look at the width logically. It's measuring the length of the interval, right? Can you have half a centimeter? Yes, it does make sense. You could actually use 7.5 as your class width. You could also just use 8. I can't use 7. 7.5 is the smallest width I need to get the number of classes I want. But I could use anything larger than that. So typically what you'd see is this. Of course, this just gives me the opportunity to show off one of my favorite functions. I just mentioned this is a favorite function. Might be an exam question. That's the ceiling function. So that is what I would use. The actual function itself ceiling of x is defined unique integer n such that n minus 1 is less than x is less than or equal to n. I'll be coming back to the ceiling function later in the semester, by the way. What it does is pretty cool. It takes your value. If it's an integer, it just spits out that same value. Right, so if you plug in 5, the ceiling function is going to give you 5. If it's not an integer, it's going to round it up to the next integer. So 5.2 would go up to 6. 5.8 would go up to 6. 5 and 1/1 billionth would go up to 6. By the way, it has a sister function. What do we think that's called? The floor function. And how do you think that's going to be defined?
The opposite.
What do you mean by the opposite?
Like, so n minus 1 is greater than x, which is greater than or equal to n.
First off, that can't happen because n minus 1 is not greater than n. You take a value, subtract 1, you don't get something larger. So don't explain it mathematically, try and explain it in words, like with the ceiling. So what do you think it would do? If you put an integer into the floor function, what is it going to do? Well, for an integer. A non-integer, I agree. It's going to round it down to the nearest integer. Right, so floor of pi is 3. What if it is an integer? So if I just plug in 3, what do you think the floor is going to give me? 3. So you almost have it. It's n less than or equal to x less than n plus 1. So kind of rounds up. We actually don't look at the floor function in this class, which is a shame. But we will be using the ceiling function. Those are 2 cool functions that don't get stuck enough. Now we need to design the actual classes themselves. Well, the easiest way to do this would probably just to be, what's the smallest value? 150? Let's just start there. So if 150 is the lower limit, what's the upper limit going to be? If the class width is 8. And what is class width defined as? How do you find class width? So if the lower is 150, what's the upper have to be? 158. Sometimes math is just that easy. Actually, usually math is that easy. Then you think it has to be harder because it's math. Next, we start at 158 and go up to what?
166.
Probably not going to have enough room. $166 to what?
174.
That's 3 classes. 174 to what?
182,
182 to what?
190.
That's annoying. Okay, let's move those up. And then be 192.
190.
1, 2, 3, 4, 5, 6. And does that encapsulate all of the possible data? It does. So we're happy. I'll just separate these classes with semicolons. So those would be the classes that we would use. I have 252 commuters in a metro area. They're asked for their weekly commute times in minutes. We're going to create a frequency table, relative frequency, and then a histogram. You want to sit there and do this by hand, be my guest. Okay, so I've now uploaded that into SharePoint. That's a CSV, so I'm going to create a new notebook and then import the data. And it's not going to show. Why are you not showing it? So let's just exit out of that, exit out of that. Now you have no choice but to show. Of course you don't want to show. Why don't you want to show it? I'm not giving you the option to show it. I'm going to do this. Exit. Now, you will. So there's all of our commute times. Histogram is really simple. Right, so insert your statistical chart, it's literally right there in the middle. Screen. And then just do the histogram. You don't want the line. That's actually a Pareto. Come over here, select data. Let me just do this. And we can adjust this. So if I double click on there it is. Just click on the chart, go to options, chart options, size. No, that's not what I want. Properties. No. Where? Oh, so the axis. Double click on the axis, you're going to see the bins. It automatically creates bins, but you can adjust that. Right, so let's say we only want 5 bins. Number of bins, set that to 5, enter. And it'll automatically choose your class width. You can also set a bin width to whatever you want. Say 5. Bin width of 5. And if I'm not mistaken, should be able to choose a minimum maximum. Is that this here? No, that's not that there. I thought I could. Choose a minimum maximum. So I figured I had to do that, I will. Thought I could. For the frequency table, what you could do now is just read it off of the histogram, right? Or kind of go the same way, create a pivot table from table range. I'll just create all of A. Move this down to rows. And also into values. But now I'm going to have to adjust this. So I just click on this, I believe it's value field settings, count. All right, so this is where we're at right now. But I don't like that it's doing each one individually, right? So if I just right click, group, pick a minimum, starting at 5, ending at 100, and by 5. Fisher distribution. Did they want relative as well? Yes. So to get a relative frequency, that is also fairly simple. Pivot table analyze it was. Options, field settings. Where is my field? Without me having to right click. Right click, show field list. I'm just going to drag this back into here, values. Oh. Click on a value, right click it, show values as, percentage of grand total. It'll bring in percents. Now I can just come over here to field settings. No, that's not it. Numbers, where is the number format? Number and how many decimal places? Let's just go for it. Okay, and now there is decimals. There's your relative frequency. With that, I could probably now just create a histogram even better from the pivot table. I haven't tried that yet. So let's delete that. Click in here, insert histogram. Oh, it doesn't like that. I think I have to do a bar. I would. And I can always make this histogram. Under design quick layout options, one of them has the bars touching. Which one was it? Really not that any of them? I know that there's one that has them touching because I do it all the time. Whatever. And do that. Just go like that. So it's definitely a lot easier than doing it. Questions there? Just continue working on my group design. There is still 10 minutes left. There's like no one here, but still, just get in your group so you can get the worksheet. That's fine. It's good. Here's one. You got this one.
How about the minutes, right?
Yeah, about to be eliminated from playoffs.